Decision tree for statistics. I decided to split this video into two parts. This first part is about differences, significant differences between means. All right, it's difficult to tell sometimes which type of statistical analysis you're going to run, and I'm going to go over this real quick video to show you how I do it. All right, so which test should you use? It depends on basically two things. First is your types of variables that you're using, right? Nominal, ordinal, continuous. There is a fourth called interval. Do not use those. Quick review on which is which. Let's take a subject. Let's say it's a fish. Hello, fishy. So a nominal variable about the fish would be the type of fish. Oh, it's a shark fish. Oh, it's a tuna fish or a starfish, right? Where the nominal variable puts them in specific groups or categories. The continuous variable would be how much the fish weighed, or if you measured him with a tape measure, how long was he? An ordinal variable, if you made your own little table of numbers that represent the size of the fish. So 1 would be a little tiny fish like Nemo. 2 would be a bigger fish like an eel or something. All the way up to 10. 10 would be a whale shark, right? The biggest fish in the ocean. So you see that order there. 1 is the smallest, 10 is the largest, and as the numbers increase, so does the size. That's ordinal, also called rank order, something like that. But that's the types of variables that you're going to use in your statistical analyses. And the second thing you need to know is, what are your questions, right? What are you asking? What are you looking for? So the questions basically break down into two parts. Are you looking for differences between groups? What that really means is there a significant difference in the DV of whatever you're measuring in everybody between group means? That's the difference part. Okay? The second part of that is, are you looking for a relationship between variables? In other words, when one value of a variable changes, will it influence a change in another variable? It's the cause and effect type of idea, right? Does one variable change cause another variable change? But we got to be careful. We can't say cause and effect. But that's the second half. First half is you're looking for significant differences. The second, when you're looking for significant relationships. So the relationship variables can be literally anything. They could be nominal. We don't like nominal. We prefer that they are continuous or scale or ratio, right? Just regular numbers that have fractions in them, and 0 means 0. We prefer them that way, but we can also use ordinal variables and even nominal variables in relationship type things. But let's keep moving on. I have a table of data here, and I want to see if you can decide which ones are nominal, ordinal, or continuous. If you get good at identifying what type of variable is, that's half the decision tree right there. So just make sure you're good at defining what type of variable you're dealing with. So age, that's obvious. That's continuous, right? You can be 43 and a half years old. So, and it's just a larger number set. That's usually the way you tell if it's a continuous variable. If you got large numbers in there, then it's continuous. All right. Gender. Gender is nominal, right? Categorical. It puts people in one group or the other. It's a grouping variable. Gender, nominal. Boom. Ethnicity, same thing. It's nominal. It puts people in one and only one group, right? 1 white, 2 African American, 3 Hispanic, 4 Asian American, etc., etc. Where a number means a group. It doesn't mean a number. All right, type of therapy, same thing. This is nominal, right? 1 could be CBT, 2 could be biofeedback, 3, etc., etc. Again, a number isn't a number. A number is actually a name of a category, but for SPSS purposes, we put numbers to represent specific values. That makes it a nominal variable, categorical variable. Level of education, that is ordinal, right? A 1 means low education, and I see a 7. A 7 means high education. So the higher the number, the higher the rank or the order of whatever you're doing. So there's several ways to think about that. The main type of ordinal variable that you will probably use will be the Likert scale, right? 1, I hate it. 5, I love it. Something like that, where as the number increases, so does the strength of the characteristic. Okay, so that's ordinal. And social economic status, that too can be considered ordinal, right? 1 is low income, and what do we see? A 6. 6 is high income. So the larger the number, the more the income. Daily calories, those numbers are huge. So right off the bat, you should know that's continuous. Weekly exercise, same thing. These numbers are huge. These are continuous variables, and so is weight. So let's take a quick glance, see if I got them right. Bam. Yes. Continuous is age, daily calories, weekly exercise and weight. Nominal are gender, ethnicity, type of therapy, and level of education, social economic status are ordinal. Now, little sidebar here. Ordinal variables, they're kind of useful. You can use them as nominal variables if you want. And sometimes you can use them as continuous variables if you want. So just remember, these are very, very multi-talented ordinals. I think that's why they got created in the first place. So moving on. All right, back to your questions. If you're looking for a difference between a group, and by difference I mean significant. Significant means that the difference between the two means is large enough to be significant. And remember, it's the difference of the means of some DV, whatever you're measuring. It's either going to be a t-test or an ANOVA. So there's 3 kinds of t-tests. The first one is a one-way t-test, and that is if you're comparing a sample mean to a population mean or a stated norm or a stated claim, something like that. So a good example would be the SAT company says that the average SAT score for mathematics was 500. Boom. But Mrs. Johnson, she's a math teacher, she had all of her 11th graders take the SAT, and she took their average math test scores, and her average was 550. So she's claiming that her test sample is significantly higher than the stated mean of 500. That would be a one-way t-test. The sample is Mrs. Johnson's math class, and the population is the SAT people came out and said that it was 500. So that's a one-way t-test, also called a one-sample t-test. The independent t-test, that is your most used. That means if you have 2 separate groups and you want to compare a DV between 2 separate groups. Example, Mrs. Johnson wants to see if the boys scored higher than the girls or lower than the girls on the tests. Okay, so the DV would be the test scores, and the independent variable would be gender, right? Male versus female. This is also called a 2-way or a 2-sample t-test. Last but not least is called the paired t-test. And with this one, there's only one group. That's how you tell it's a paired t-test. Everybody gets the first test. That's what we call a pre-test. And then something happens. You get some training or some education or a shot or some therapy. And then they give you the same test again after whatever they did, and that's the post-test. That is a paired t-test. There's only one group. So the example would be Mrs. Johnson gave a final exam on the first day of school, and everybody failed. But then 4 months later, at the end of the semester, she gave everybody the exact same final exam, and everybody passed. So that would show improvement. So that means whatever she did between the first test and the second test showed improvement in whatever you were measuring. And in this case, the DV would be test scores again. So good way to remember the t-test. The first T stands for 2. 2. So with a one-way t-test, you're comparing one mean, the sample mean, versus the population mean. Independent t-test, you're comparing 2 separate means, 2 independent means. And the paired t-test is you're comparing 2 separate measurements. Okay, that's how you remember a t-test. The ANOVA stands for analysis of variance. Has many tails. You're going to use the ANOVA if there's more than two groups, right? 3 or more groups, you're supposed to use the ANOVA. And the main one is the one-way between group test. A good example is that of that is who can do the most push-ups in an hour. That's the DV, number of push-ups in an hour. And that between the sailors, the Marines, the soldiers, the Coast Guards, the airmen, etc., etc. So you have one IV called military branch with the 5 levels, right? Navy, Army, etc., etc. And the DV is the number of push-ups. That's a one-way between group. There's also called a one-way within group. It's like a paired t-test, but instead of 2 measurements that are the same, this has more than 2 measurements that are the same. So this also goes by the name of repeated measures. That's the term I prefer. Repeated measures. It's defined, right? It's a measure that's repeated. But the books like to call them one-way within groups. A good example of that is you wanted to see if a new therapy would decrease depression in people with severe depression. So you give them a baseline test for depression. That's your pre-test. You go ahead and do your therapy for a couple of weeks. Then you give them the same depression test after the therapy. Hopefully it went down. And then 6 months later, you give them another depression test to see if it lasted, your therapy lasted for a long time. That's a one-way repeated measures ANOVA. One-way within group repeated measures ANOVA. And the last one is it if it has both of them, if it has a between group and a within group design in the study. So an example, let's go back to our depression scores, right? We give them a pre-test, we give them the therapy, we give them a post-test, 6 months later we give them a follow-up. But we also want to see if there was a difference between the males and the females. So that's the between group would be the gender, and the within group would be the 3 repeated measures. And then the last one in reality is if you got more than one DV, that would be a MANOVA. So back to our push-ups and the military guys. If we wanted to see if there was a significant difference in push-ups and sit-ups, so you got 2 DVs, you got push-ups and sit-ups, that would make it a MANOVA. So let's keep going. I almost forgot. If you're going to control for any variable, such as age or weight or IQ scores, anything like that, with an ANOVA, that makes it an ANCOVA. Whatever variable you're controlling for is called a covariate, and it has to be a continuous variable. If it's a categorical variable or a nominal variable, it simply becomes another IV in ANOVA, makes it a factorial ANOVA. But again, if you're going to control for a continuous variable and an ANOVA, that makes it an ANCOVA or a MANCOVA. So if you hear the word difference come out of your mouth, it's either going to be a t-test or the ANOVA. Got it? If you're looking for differences between groups, t-test or ANOVA. Some general information. If your data violates too many of the assumptions, you should probably use the non-parametric version of the test. That's not always true, but it has been my practice, and I've done literally thousands of these. It rarely matters which way you want to go with a parametric or non-parametric version when it comes to the results. So, example, if you had a significant difference in your ANOVA, but the data violated the homogeneity variance and normality, you would switch to the non-parametric version of the ANOVA, probably the Kruskal-Wallis test. And if you 99,000 times out of 100,000 times, you're going to get a significant difference in the Kruskal-Wallis test as well. Okay, so, but the main thing is a non-parametric test is not considered as powerful as a parametric test. You should use a parametric test if possible first. If not, switch to the non-parametric. Part 2, if the data is ordinal, if you're using ordinal data, then you should probably use the non-parametric version of that test. All right, I'm losing my voice. So what I just went over here will probably represent about 99% of everything that you will do in your statistical world. Everything, 99%. There are a few others that I didn't go over, but they're so far and in between, I'm not even going to touch on them. And like always, practice makes perfect. Practice these. Practice, practice, practice. So the more you do it, the easier it becomes. Again, it all boils down to two things. What do your variables look like? What types are they? And what your questions are. Are you looking for a difference or a relationship or an association? So that's it. MGZ out.